Hello students, welcome to the session on data structures. In our today's lecture, we are going to discuss about the spanning tree. Okay, spanning tree is a subgraph from your graph where it will be having the vertices and edges. Okay, say consider if you are having 1, 2, 3, 4 vertices, then if you are having edges like this which will be forming a circuit or as a cycle within it. Okay, then if you are taking a part of that particular graph, okay, part of that particular graph, say if you are having 1 2 3 and 4, 1 2 3 4, then if you are having edges like this, then if it is forming a cycle, though it is called as a graph, right? But if you are taking a subgraph of it and which will be not forming a circuit, then it is nothing but a spanning tree. Okay, spanning tree, it should not form a circuit or as a cycle, it should not form. If it is not forming that particular cycle, then it is called as what? Spanning tree. Okay, then when we are reading it technically, what will happen, you see, just I'll delete this. Okay, see here, a spanning tree for a connected undirected graph where G is vertices and edges. Okay, undirected tree and contains all the vertices, it will be containing all the vertices but it will not contain all the edges. Okay, it will not form a cycle. Okay, it can also defined as a subgraph of T where it will be having all the vertices and edges, is a spanning tree of graph G if T is a tree. It should not form a cycle. If it is not forming the cycle, then it will become a tree. A spanning tree of a graph should include all the vertices and a subset of edges. It may contain subset of edges, so it should not contain all the edges. If it is containing all the edges, then it will be forming the cycle. So it should not contain the all the edges, it can contain subset of the edges. Okay, by the theoretical one you people will understand few things, but when we are going for the example, it will be more clear to you people. Okay, just we'll go for the example so that it will be clear for you people. Okay, now I'll close this and we'll go for the example. Okay, see this, in this figure you are having some graph where you are having 1 2 3 4 as vertices, and we are having a path from 1 to 2, 1 to 3, 1 to 4, and 2 to 4, 2 to 3, 2 to 1, and each and every vertex is having the path from one to another. Okay, so if you want to form a spanning tree of this particular graph, then what we will do is we will be selecting all the vertices at least once we will be having within that particular tree, but we will be having the subset of these edges. We won't have all these particular edges. Why? Because if you are having all the edges, then it will be forming a cycle. When it is forming a cycle, it will not become a tree. Tree should not have any cycles. If you are taking this 1 2 3 and then 4, then it is nothing but a tree. Okay, so consider if you are taking like this 1 and 2 and then 4 and then 3, then also it is tree. Okay, if you are forming one more edge over here, then it will be forming a cycle, which should not happen. Okay, if you are forming a path from 1 to 4, then also it will be forming a cycle between 1 to 4, then it should not happen. Okay, that is what the meaning of your spanning tree is. Means to say that you should have all the vertices, but it is not mandatory that you should have all the edges. It should be there, it should be seen that all the vertices are present in your tree, but it should not contain all the paths within it. Okay, now try to observe the examples over here. When we are having this kind of vertices and edges in your graph, then when I am taking a spanning tree from that particular graph, then see in the first one I do have a vertices 1 2 3 4, all the vertices I'm having, but I'm not having edge between 1 to 4 and 1 to 3. So even if you are taking any one of them, it will be forming the cycle, but we are not taking that in order to form a tree. In the same way, we are going for the second one. We are having 1 to 2, 1 to 3 and 3 to 4, which is not having any cycle over here. Okay, like this we will be forming the trees from the graph, so that it should not form any circuit, it should not form any circle. Okay, so when it is not having any cycle from the graph, then it is nothing but what? Tree. Do remember it, okay. Now I'll go for the remaining part. See, in this way only we can form different kind of trees from that particular example like this: 1 2 1 2 to 3 3 to 4, and then you can form one more tree from 1 to 2 2 to 3 and 2 to 4. Like this you could have one more tree also, like 1 to 2 1 to 3 1 to 4. You could have anything, but it should not contain any cycle within that particular path. Means to say that if you are starting from 1, you could reach the destination like 2 3 and 4, but it should not form a cycle like 1 to 2 2 to 3 3 to 1. Again it should not go to 1. If you are approaching it in that particular way, then it is nothing but a spanning tree, I can say. Okay, I hope the example is clear to you people. If it is not, just comment on to this so that we could make one more video onto it. And here one more important topic that we are going to discuss is your Prim's algorithm. By using the Prim's algorithm, how we will create the spanning tree. But try to understand what is minimal spanning tree is. Now I'll take one example here. Say consider, as we are having the previous one, I'll be taking those only: 1 2 3 and 4. 1 2 3 4. See, these are the vertices from 1 to 2 1 to 3 and 2 to 4 3 to 4 and 1 to 4 we are having the pass, and 2 to 3 also we are having the pass. See, each and every edge, if we are mentioning with any number, if we are mentioning with any weight, then it will look like this: 1 2 1 3 4 some 3. See here, weight of that particular path from 1 to 3 is 2, from 1 to 2 is 1, okay, from 2 to 3 is 1, and 3 to 4 is 4, and 3 to 2 is 3, and 2 to 4 is 3. So we are having a topic called minimal spanning tree. Minimal spanning tree or minimum spanning tree, you could say. Minimum spanning tree is a concept where you people will be creating the path of all the vertices which will not form the cycle, which will be getting a minimum path from all the vertices. Okay, so in order to create that, how you people will be selecting the vertices? Says here, from 1 to 4 we are having weight as 1. Okay, I have taken that. From 1 to 2 I am having the path as 1, I have taken that. And from 3 to 4 we are having path as 3, so we can't take that. Okay, so from 1 to 3 we are having what path as 2. See this: 1 and 1 2 2 plus 2 4. Path of this particular spanning tree is 4. Remaining any path that you will select, you people will be exceeding this particular length. Okay, so we will be finding that particular minimum path from all the vertices, I can say. In this way you people will be creating some minimal spanning tree. If you are not getting it, just try to understand with this particular example. Okay, say in this example only I'll try to arrange the edges weight. Okay, edges weight like 1 to 2 is 1, okay, 1 to 3 is 1, 1 to 4 is 1, okay, 2 to 4 is 2, and 3 to 4 is 3, and 2 to 3 is some 3. Consider these are the weights. Then how you people will select the minimal spanning tree? From 1 I can reach 2 by traveling 1 kilometer. Consider that as kilometers. Okay, so from 1 I can reach 4 by traveling 1 kilometer. This 3 is for 2 to 3 months. Okay, and then if you can reach 3 by traveling 1 kilometer. So I can cover all the vertices by following these particular paths. Means to say that 1 and 1 and 1, then you people can travel 3 kilometers in order to see all the vertices in your graph. In this way you people will be selecting the minimal spanning tree, which will be not forming circuit, which will be not forming circle, I can say. Okay, now we will discuss the same technique but by using some Prim's logic, Prim's algorithm, I can say, where you people will be using a different kind of logic by using the Kruskal's method and Prim's algorithms. In the Prim's algorithm, what we will do is we will be selecting any edge. Okay, we will be selecting any edge, and by that edge we will be having certain adjacent vertices. Adjacent vertices will be having the adjacent edges also. We will be selecting the adjacent edges adjacent edges, so which will have the less weights when we are comparing with the other adjacent. Okay, see, when we are going technically, Prim's algorithm generates minimal spanning tree. Prim's algorithm generates minimal spanning tree by selecting the minimal means to say that we will be having the smallest weight in your graph. That particular edge will be selected, and after that adjacent edges which are having the less weight of edges, those will be selected. In that way only we will be selecting the adjacent to each and every one by using what? Prim's algorithm. Okay, theoretically you will understand this much only, then when we are going for the example, it will be more clear to you people. Okay, then just look at your example. Okay, I'll close this, I'll delete, and now coming to your example, see this graph. Okay, where you are having v1, v2, v3, v4, v5, v6 vertices. Okay, v1, v2, v3, v4, v5, v6 vertices. 6 vertices are there, and within that we are having so many edges. Okay, among these edges we will be picking one edge which will be having the minimum weight. See here, the minimum weight is what? 1, 2. From v1 to v4 we are having the path as 1. From v1 to v2 we are having path as 1. By default, as we are having the v2 as vertex, v1 and v2 as vertex, then consider that particular vertex first. Okay, then I'll go for the drawing of this particular graph. Okay, see here, in this first step what I have done is I have selected v1 and v2 as vertex. Okay, v1 and v2 as vertex, which is having the path as what? 1. Okay, and after this in this only you are having what? Adjacent edges as v1 to v6 and v2 to v3. In this, which one is the lesser one? v2 to v3. So in the next step I will be selecting v2 to v3. See here, see, in the first step I have done with what? v1 to v2. In the second step I am selecting what? v2 to v3. In the same way I will go for the adjacent vertices of v3. v3 is having adjacent vertices as v2 and v4 and v1, and that's it. Okay, the smallest edge is what? v4. As already we have done with v2, we will be selecting what? v4 here. Look at this particular one. Now we have done with what? v1 to v2 and then v2 to v3. Now we have done with v3 to v4, and later on we will look at our graph. For this v4 we are having adjacent as v1, v5 and v3 and v6 also. See, v5 is having the path of 4, okay, and v6 is having path of 5. So which one is the smallest one? v5. Then we will be selecting what? v5. I'll remove all these things. Okay, then in the next step I will be adding v5 into my tree. Okay, see this, see here, see, in the first step what I have done is I have done with my v1, v2, and in the next step v2 to v3, and in the next step I have done with v3 to v4, and in the next step what I am doing is I am going for v4 to v5, which is having the lesser path as 4. Okay, and then next I look at the v5 and I will search for the adjacent edges. See, for v5 we are having adjacent vertices as v6, v1, v2, but if we are forming for, see here, v5 to v6 we are having the weight as 3. Okay, weight as 3. From v5 to v1 we are having weight as 3, and v5 to v4 we are having weight as 4. But see here, we are having two paths which are having the same weights, but if you are going from v5 to v1 it will be forming a cycle. Okay, so we should not select this particular path. Then we should go for what? v6. Then we will be taking the path from V1 to V2, V2 to V3, V3 to V4, V4 to V5, and from V5 to V6. Now in the next step, we will do that only. Okay, see here. See here. In the first step, I have selected this V1 to V5, V1 to V2, and V2 to V3, and V3 to V4, and V4 to V5, V5 to V6. See, in the figure you need to observe, is there any adjacent path which is having the lesser weight? Then you need to take the decision whether we have traversed with all the vertices or not. Okay, then what I will do is, I will go through my graph. See here. In this graph, you can see adjacent vertices of your V6 is V1, V5, and then V4. If you are drawing any edge among these three, it will be forming a cycle. See, already it is done. Okay, we have reached what? V1, V2, V3, V4, V5, V6. All the vertices have been present in your, already has been present in your tree. So you have reached one step. And now look at your output. This is your final output. That is, we are having all the vertices and we are having the subset of edges. We are having all the vertices and subset of edges. In this way, we will be using what? Prim's algorithm. I hope it is clear to you people. If it is not, just comment onto this so that we could make one more video onto it. Okay. Resulting graph can be obtained by using a minimum spanning tree in which the comparisons made by the tree algorithm totally 5. That is, if you are having 6 vertices, then we need to make n-1 comparisons so that we will be having edges also in that particular order. See here, in this we are having 6 vertices and we are having 5 edges over here, like 1, 2, 3, 4, 5. Okay. If you can include few more edges without forming the cycle, then you can. But the rule and regulation is that your edges should not form any cycle, any circuit over there. Okay, that's it for now. I hope you people might have understood this. Once again, I'll repeat what the spanning tree is. Spanning tree is a tree. So consider if you are having 1, 2, 3 as our graph, and we are having a cycle like this 1 to 2, 2 to 3, and 3 to 1. If the weight of this path is 1, if the weight of this path is 2, if the weight of this path is 3, then by using minimal spanning tree concept, we will be forming a trees like this 1, 2, and 3. See, 1 to 2 we are having 1, and 1 to 3 we are having 3, and 1, 2, 3. From 1 to 2 we are having 1. From 2 to 3, I'll remove this. From 2 to 3 we are having 2, 1, 2, and then I can go for 1, 2, 3. From 1 to 3 we are having 3, and from 3 to 2 we are having some 2, and I'll remove this edge. Don't consider it. If you are considering it, it will form a cycle, then it won't become a tree. See here, in this the path value is 5, as it is 3, as it is 5, as it is 2. The complete path is 5, and when I am considering this 1 to 2, 1 and 2, it will be forming as 3. Path value is 3, and when I am considering this, it will be giving us 4, path value as 4. But see, if I am taking this example 1 to 2, which is 1, and 2 to 3, which is 2, this value will be 3. See, if you are going like this 1 to 2 and 2 to 3, the path of the value is 3. Okay, the sum of the path of the values will be 3, but it will be having all the vertices in your graph. In this way, we will be selecting what? Minimum spanning tree. And in order to get the minimum spanning tree, we will be having 2 methods. One is Prim's algorithm, one is Kruskal's algorithm. And Prim's algorithm that we have seen, I hope you people might have understood this. Try to understand the logic. We will be selecting the vertex which will be having the minimum weight of the edge, and adjacent vertices will be seen. See here, vertex will be seen and adjacent vertices will be seen, which will be having the minimum edge. We will be inserting that into our trees, and we will look at that particular point that it should not form any cycle. I hope it is clear to you people. If it is not, then just comment onto it so that we could make one more video onto it, so that it will be clear to you people. Okay, I hope it is clear to you. That's it for now. See you in the next one. Thank you.